Hi, welcome to Three Crowns Academy. My name is James Pearce, and in this module we are going to look at doing some more advanced text pre-processing than we did the first time we looked at it. Hi. Previously, when we pre-processed our text, we used individual words. We call these words tokens. Now, instead of using just one word, we can use 2 or 3 word phrases. In text processing, this is known as n-grams. N refers to the length of the phrase. So 1 would be a single token, 2 would be 2 tokens, and so on. So 2 grams refer to 2 word phrases. Phrases like very good and not bad can be more useful in conveying emotion than single words on their own. In our advanced pre-processing, we're going to look at 1 and 2 grams. There is an option for this in Count Vectorizer and its peers, and yes, there are others, as we'll see later in this module. And note that a token does not need to be a word. It can be syllables, collections of letters, or even emoji. So let's have a look at breaking up this sentence. The fat cat sat on a mat into 1 and 2 grams. And here they are. So we've got our normal single tokens on the left, the fat cat sat on the mat, and then we have each pairwise version of this. So you can see by using 1 and 2 grams, and if we use more, it would get even worse, but we're making more and more features and phrases and words that we're looking for. Now, you can go through all of this in the module Refine the preprocessing.ipynb notebook, and I encourage you to do so. I'm now going to talk about regular expressions. Now, Count Vectorizer and other text processing libraries can let us choose how to split up text into tokens. This is known as tokenizations, as we've seen, and typically this is done using regular expressions. Now, I'm not going to go into regular expressions in detail here because they're quite complex, but I'll just give you some hints. There's a whole heap of stuff out there on the World Wide Web, on the internet, about regular expressions, and I encourage you to find a site, and I've put a few in the notebook. Find a site that does it for you and play around until the regular expression is giving you what you want. And for those of you who are more interested in this stuff or already know it, great. I use regular expressions occasionally, so I don't keep my knowledge up to date, and I don't know off the back of my hand what to do, but I do have an idea of where they can be used, and that's what I encourage you to do. So let's have a look at what our pipeline is going to look like with using regular expressions for tokenization. So we start with our reviews, and then we tokenize. Now this \b \w plus \b is an example regular expression that we might use to break up word boundaries and find any number of words in between them. We can use all sorts of different things, and you can see this in the notebook. So then we go on to form our 1 and 2 grams off the back of the tokenization and go from there. The next thing I want to talk about is stemming. Stemming is the process of reducing words back to their prefixes. So we're literally chopping words back to their stem. So I'll give you an example. Think of this word of stand and its variants: standing, stands, and stood. Now by stemming, we chop everything back to its basic form. So for stand, standing, and stands, we've got the same thing, stand. But for stood, we can't chop that into stand, so it stays as stood. We can do the same thing with non-verbs, so soft, softly, adverb softer, adjective form, softest. We would reduce those all back to soft, which is pretty good. But there's a related concept, and this one is more complicated and requires a bit more sophistication in the libraries you're using. So with lemmatisation, we actually take the words back to their dictionary root. Stand stays the same, standing becomes stand, stands becomes stand, all the same, but stood now feeds back to stand. So it's a better way of finding out the intent in a word. In the Jupyter Notebook, you will see how we do this. I use the very popular and very capable Spacie library to form our lemmatisation, but it also lets us identify parts of speech, and you'll see all of that. So now our pre-processing looks like this. We have our reviews, we tokenize them using a regular expression, we have 1 and 2 grams, and then we lemmatize them. The next step then is to look at a term document matrix, as we did before, where we used count vectorizer. But what we're going to do now is use something different. We're going to use TF-IDF, or term frequency inverse document frequency. Count vectorizer gave us our term document matrix by using a count of each token for each row that we looked at for each review. What TF-IDF does is, instead of giving us a count, it gives us an importance score. Now I've put into the notebook how some of these are calculated. There's a few different ways, but all they're trying to do is find out what is the most important token in the context of the corpus of documents that you're looking at, to find out how important it is to this particular review or document. You can read a lot more about that in Wikipedia. You can look at the TF-IDF vectorizer page in scikit-learn. That will tell you a lot. Now, TF-IDF vectorizer that I just mentioned is the companion to count vectorizer that we will use for creating our term document matrix. So this makes our process now. We get the reviews, we tokenize using regular expressions, we get our 1 and 2 grams, we lemmatize, and then we use TF-IDF vectorizer to give us our term document matrix, and we go from there. The final thing I'm going to talk about is stop words. Now, you'll remember when we built our word cloud, we used stop words to get rid of nonsense words or junk words, or words that aren't going to convey any positive or negative sentiment. So in terms of what we're doing, there's different ways that we can do that, and I'll show you some using Spacey. But that's something that you can make specific to what you're doing. If you have special words that you want to exclude in the context of your reviews or your documents, you can add that into stop words and supply that in. In our next module, you'll learn to take the output from TF-IDF vectorizer and train a naive Bayes classifier to predict the sentiment. Thank you for learning with 3 Crowns Academy.